Okay, so let's look at this problem here, number 6. We have a congruency statement that's given. We're also given midpoint and another midpoint. We're given 2 midpoints. Okay, so what's the first step? Is write all this down as our first statement. So it's going to be segment AB congruent to segment DE, and then we got B is midpoint of AC, and then E is midpoint of DF. Okay, and that's given. All right, so what is our steps on writing these proofs? First step, change any congruency statements to equations. Okay, let's go ahead and do that. So we have a congruency statement. It's right there. I'm turning him into an equation, namely AB equals DE. Okay. How do I do that? Def of congruence. Okay, notice that the line above AB and DE go away, because now we're talking about measure AB is equal to measure DE. What's the next step? Is if you're given midpoint, you change him into equation using definition of midpoint. And what does the definition, now I'm looking at my proof chart, what does definition of midpoint let us say? It's right here, definition of midpoint. If B is midpoint of AC, then AB equals BC. Namely, the left side is equal to the right side, because midpoint means exactly in the middle of the 2 points. So that means the left side is equal to the right side. Left side is equal to the right side. This is the equation we can create if we're given midpoint. So we look at our figure again here. B is the midpoint of AC. B is directly in the middle of A and C. That means this left side is equal to the right side. That's the equation that we can create. So it's going to be AB is equal to BC. Right. Notice here also, E is midpoint of DF. Right. E is directly in the middle of D and F. That means the left side is equal to the right side. Again, midpoint definition. So we're going to say DE is equal to EF, or measure DE is equal to measure EF. Okay, great. So now what's the next step? Right. Whoa, that's not what we want. We want the steps. We're here. What's the next step? It's if we have 3 points on a line, given the figure, we use seg-adpos to create more equations. What does seg-adpos let us say? Is first part of the segment plus second part of the segment equals the whole segment. Okay. So we're looking over here and looking at the figure. Do we have 3 points on a line? Yes, we do. So we're going to create an equation. First part plus second part equals the whole part. Okay. Do we actually even need to do that? I don't think we need to do that for this problem. Okay. We could just use these 3 equations here to get to that proof statement. Okay. But yeah, we would. Most of the time we would use seg-adpos on these 2 figures here. Okay. So anyhow, now we're looking at our 3 equations we have. It's 1, 2, and 3. So I'm trying to get BC equals EF. I'm trying to get BC is equal to EF. Basically, I want to change this DE right here into a BC. So how do I do that? Well, I can change DE into AB using this equation, right? I could take this AB and I could put him right there in the place of DE. Right? So I'm going to go ahead and do that. Oh, I didn't. They didn't do that. Okay, let me just erase what they have, and I'm going to put what I have. Okay, so I'm going to put AB is equal to EF substitution. Okay, now what can I do? Now I can take this BC over here, right? He's equal to AB. I could take the BC and I could put him right there in the place of the AB. Right? Substitution again. So we've got BC is equal to EF substitution. And we're at the proof statement. But the proof statement is a congruent statement. We have equation. So we need to go ahead and convert this into line segment BC congruent to line segment EF. And that's def of congruence. And that's that problem.